A horizontal tangent means a horizontal line that's tangent to a graph. So let's say this is a graph of our function. This is a tangent slope right here, a tangent line. Touches only at one place right here. Okay, but it's not horizontal. So this is what they're looking for, where a tangent line is perfectly horizontal. And this is also a tangent line in the graph I drew. Okay, so how are we going to find those? You could graph it, you could use guess and check or using some special graphing software, but we have a calculus way of exactly finding those horizontal tangents. Look, what is the value of the slope here? How fast is it rising over run? The rise to get from one point to the other is always going to be 0, and the run could be anything, 2, 4, whatever. 0 divided by anything is 0, though. So in other words, if you need a horizontal tangent, you want to find where the slopes are 0. So that's what a derivative does for us. F prime of x. The derivative of x tells us about slopes of the original function, instantaneous slopes. So to take the derivative of this term, the 3 comes down and multiplies, then gets reduced by 1. The 2 comes down and multiplies, and then the power gets reduced by 1. And then the power of 1 comes down and multiplies, and then the power gets reduced by 1. And the derivative of 19 is 0, because a derivative is talking about how fast it's changing. Plus 19, that's constantly 19. It has a change of 0. Okay, so that's our derivative. We're looking for horizontal tangents, so we're looking for where the derivative is equal to 0. So we just have a quadratic equation to solve. Remember, all quadratic equations can be solved by factoring. I would solve this one by they can all be solved by factoring. It gets ugly. All can be solved by using the quadratic formula. I think a lot of these are going to be solved using factoring. It's an easier way, but if you're ever not sure of what to do, you could use the quadratic formula. So I'm trying to think of two numbers that multiply to be 12 but add up to be 8. How about 6 and 2? Those are two numbers that multiply to be 12 but add up to be 8. And if I set each factored piece equal to 0, then I get my two solutions. And we set each factored piece equal to 0 because if x equals -2, -2 plus 2 is 0, and 0 times whatever this is going to be is also going to be 0, so that'll make a true statement. So solving both those, I get x is -6, comma, -2 for our solution. Those are the places where this function has horizontal tangents. Okay, same thing with this one. You take the derivative, set the derivative equal to 0. And this one, no factoring involved. Much easier, right? Add 2 to both sides, divide by 8, so x is going to be 1 over 4, right? 2 over 8, which is 1 over 4. So that's where this graph is going to have a horizontal tangent. That's where the graph is going to have a slope of 0. X equals 1/4.